Hello and good afternoon, students. Today we're going to be learning about the different geological formations. So for example, this mountain right here in the canyon and also this volcano. And then we're also going to be covering the different mechanisms that happen to them, which causes them to change the way they look. For example, erosion or chemical and physical weathering. So first we're going to be discussing the different characteristics of the geological formations. Some characteristics may be more easier to identify based on their appearance and actions, kind of like this volcano. Obviously, you can see that it is erupting and you can observe it more, while other characteristics of these formations might not be so visible, like plate tectonics, for example. So the first geological formation we're going to be talking about is mountains. Mountains can be found in both water and land areas all over the world. Maybe some of you guys have been lucky enough to see them. They really are beautiful. There's 4 main different types of them: a fault block, volcanic, a folded, and a domed one, which I all showed right here with this specific one underneath it. And then next we're going to watch a YouTube video that actually gives you an idea of how they're created.
Mountains are found throughout the world. They come in many different shapes and sizes. Mountains can form through folding, volcanism, and faulting. Welcome to Moo Math and Science and different types of mountains. Folded mountains form when rock layers are pushed together and also pushed upward. Many folded mountains occur at convergent boundaries where continental crusts collide. The Himalayas that stretch throughout the borders of China, Nepal, India, and Pakistan is a towering mountain range. Here the Indian plate is colliding northward with the Eurasian plate. Other examples of folded mountains include the Appalachian Mountains, the Alps in Europe, and the Ural Mountains in Russia. Volcanic mountains are created when melted rock erupts onto the Earth's surface. Many volcanic mountains occur at convergent boundaries. Most of the Earth's active volcanoes are concentrated around the edge of the Pacific Ocean. This area is known as the Ring of Fire. Mount Griggs in Alaska is an example. It is located on the northern rim of the Pacific Plate. Other examples include Mount Fuji and Mount Etna. Fault block mountains form when tension causes the lithosphere to break into normal faults. At normal faults, the lithosphere drops down. The pieces left standing form a fault block mountain. The Teton Mountains is an example, and the Sierra Nevadas. So I hope that helps with understanding different types of mountains. Thanks for watching, and Moo Math uploads a new math and science video every day. Please subscribe and...
So right here is a diagram of the tectonic plates in the world. The movement of these tectonic plates is what creates volcanoes, which along comes plate boundaries which erupt and form mountains. Kind of like what the video is saying, but here's just kind of a diagram to look. There's the equator and the different tectonic plates. So different characteristics of canyons include deep, steep walls and V-shaped valleys, as you can kind of tell right here. They are cut through by rivers that are joined through resistant rocks. The movement of the river, the process of weathering and erosion, and tectonic activity are what creates these beautiful looking canyons. Next, we're going to be talking about physical weathering. Physical weathering is caused when rocks are broken down through the force of another substance onto the rock. For example, that source could be ice, wind, water, plant growth, many other things. But a good example of this is this picture right here I put onto the PowerPoint. This is in Arcadia National Park in Maine, which I've actually been to, and it is breathtaking. But the rocks look like this because the constant crash of waves against it caused them to break down like that. The other weathering we're going to be discussing is chemical weathering, which occurs when reactions between rocks and any other substances, like air or water, dissolve the rock, which then causes it to fall apart. A great example of this is this photo right here that I included. This is a blue basin in Oregon. As you can tell, the claystone is more of a greenish color. It's not so tan, which is caused by chemical weathering in a mineral called selsonite. Next, we're going to be discussing erosion. So if a student was to ask questions like, why do streams and lakes get so muddy after a storm? Or what causes valleys to form? And why are rocks at the bottom of a river usually rounded? The answer to this is all erosion. So I included this chart right here to kind of help explain it. Weathering is the actual process that causes the rocks to break down, while erosion moves the sediments downhill to another place. Erosion can be caused by natural elements like wind and glacial ice, which causes the surface of the earth to get worn down. So the final step we're going to be talking about is deposition. Deposition occurs when the agents, wind or water erosion, lay down sediment. I put this chart in here because it's easier to understand when you're looking at it of the steps. The first step is weathering, which is the process of it actually breaking down the substance. Erosion next is the movement of the sediment from one location to another by the means of water, ice, or wind. And deposition is when that particle has landed in another location. We're going to be going over different misconceptions that students may have on this topic. The first one is that all volcanoes erupt violently, when the truth is that the determination of whether a volcano will erupt explosively or fusively depends on the level of silica and dissolved gas in the magma. Students may tend to believe this misconception because many science teachers use the basic baking soda and vinegar model to represent what a volcano eruption is like, when that just doesn't accurately model what an eruption is like, so it may lead to students thinking that they're always very violent and explosive. Next, we're going to be going over the second misconception, which is that erosion is always bad. It's kind of funny thinking about this because when I was a kid, I remember thinking this for a while. But the truth is that erosion does have a positive aspect to it. Without erosion, rich, fertile farming areas like the Nile and Mississippi would not exist. Some students may get this conception that erosion is always bad because many science lessons focus on the negative aspects of erosion, like ecosystem destruction and soil loss, but there is some positive aspects to it.